Hello, my friend. I'm genuinely glad you're here, whether you're listening late at night, driving, or just letting your thoughts wander. I want you to imagine that we're sitting together, calmly talking, not about formulas or exams, but about how the universe actually behaves. Physics isn't a cold subject. It's the most human attempt we've ever made to understand reality. Now let me start with something that might sound uncomfortable. What if I told you that something Isaac Newton explained in school was misunderstood? What if the way physics was taught to us, especially time, was simplified so much that it became misleading? Most people leave school believing physics is finished, fixed, mechanical, dry, but real physics is alive, subtle, almost philosophical, and today, I want to guide you through that reality, calmly, clearly, and honestly. Before we go any further, do me a small favor. If you enjoy thoughtful content like this, like the video and share your thoughts in the comments. Interaction isn't just good for the channel, it sharpens understanding. When we question together, we learn deeper together. Now let's begin. Video topic: time doesn't flow. Time doesn't flow. I know how strange that sounds. Every clock you've ever seen tells you otherwise. Every calendar, every memory, every aging face seems to argue against it. But physics, real physics, tells a quieter, more profound story. To understand it, we must start where modern physics began, with a young man named Isaac Newton. Newton's world, a universe that made sense. Newton lived in a time of chaos. The heavens were mysterious. Motion seemed unpredictable. Nature felt ruled by hidden forces, and then Newton did something extraordinary. He unified motion, force, and mathematics into a framework so powerful that it still moves spacecraft today. He didn't just explain falling apples, he explained the moon. Newton gave us laws that worked, and because they work so well, we stopped questioning their assumptions. One of those assumptions was time. Newton believed time was absolute. It flowed evenly, endlessly, the same everywhere in the universe, whether anything happened or not. In his own words, absolute time flows equably without relation to anything external. And for centuries, this idea ruled science. But here's the key point most people never hear: and Newton never proved time flows. He assumed it, because it was reasonable, intuitive, and useful. Physics advanced with that assumption, until it didn't. The school version of time. In school, time is introduced as something obvious: seconds tick, minutes pass, equations include t. As if it's just another number. We're taught to treat time like a moving river, always advancing, dragging everything with it. But physics is not built on intuition. It's built on measurement, and when physicists learned how to measure time precisely, something unexpected happened. Time stopped behaving like a river. What physics actually measures? Let's slow down and be precise. Physics never measures flow. It measures change. A clock doesn't sense time passing, it counts repeated physical processes. A pendulum swings. An atom vibrates. A quartz crystal oscillates. When nothing changes, physics detects no time. This leads to a subtle but revolutionary idea: time is not something that moves. It's something we calculate from motion. This is not philosophy. This is operational physics. If every particle in the universe froze perfectly, absolutely, time would not continue in any measurable sense. There would be no clocks. No change. No duration. Time, as physics understands it, would be undefined. Why this matters more than you think? You might be thinking, okay, interesting, but so what? Here's why it matters. If time doesn't flow, then the universe isn't moving through time. Instead, the universe is a structured collection of events, and what we experience as now is a relationship between physical processes. This changes how we understand emotion, cause and effect, gauging a memory, even existence itself. Newton's equations still work beautifully, but they describe relationships, not a ticking cosmic clock. A simple thought experiment: imagine you're alone in deep space. No stars, no motion, no reference points. You hold a perfect clock. Now imagine nothing happens. The clock doesn't tick. No atoms vibrate. No energy moves. Did time pass? Physics cannot answer yes, because without change, time has no meaning. This is the first crack in the old idea: Newton wasn't wrong, he was incomplete. This is important to say clearly: Newton was not wrong. His framework is still essential, but Newton described a useful approximation of reality, not its deepest structure. He gave us tools. Later physicists asked deeper questions, and those questions led to something profound. Time behaves differently depending on motion, gravity, and energy, but that discovery comes later. Now, understand this: physics does not require time to flow. It only requires that change can be ordered, and ordering change is not the same as experiencing flow. Your everyday experience, explained, not dismissed. Let me be clear: your experience of time is real. You remember the past, you anticipate the future, you feel moments slipping away. Physics doesn't deny this. It explains it. Your brain is a physical system, processing change, storing patterns, predicting outcomes, the sensation of time passing. emerges from memory and expectation, not from a universal ticking mechanism. That realization doesn't make life meaningless. It makes it more precise. Where this journey is going in the next chapter, we'll take Newton's foundation and push it forward. We'll explore why time behaves differently for moving objects, how gravity reshapes time, why now is not universal, and how modern physics quietly abandoned the idea of flowing time, all without speculation, all grounded in tested, repeatable physics. For now, let this idea settle. Time doesn't flow, events exist, change happens, and physics measures relationships between them. Let's continue calmly, because what we're about to explore isn't dramatic or mystical. It's quiet, precise, and deeply grounded in reality. Up to now, we've talked about Newton's world, a universe where time exists independently, ticking along no matter what happens inside it. That model worked beautifully as long as everything moved slowly and gravity stayed gentle. But physics doesn't stop when equations work. Physics stops when nature disagrees, and nature did disagree. The problem Newton couldn't see. Newton imagined motion as something happening in time. Objects move through space, while time simply waits in the background. But there was a hidden assumption here, one no one questioned for over 2 centuries. That time is the same for everyone, everywhere. As long as humans walked, ran, and threw objects at everyday speeds, this assumption survived. Nothing contradicted it, but the moment physicists learned how to measure motion with extreme precision, especially light, the cracks became impossible to ignore. Why light changed everything. Light is not just illumination. It's a physical signal, the fastest one in the universe. When scientists began measuring how fast light travels, they found something shocking. Light moves at the same speed for everyone. No matter how fast you're moving. No matter which direction you travel. No matter who measures it. This single fact shattered the Newtonian picture of time, because if speed equals distance divided by time, and distance can change, then something else must change too. That something was time itself. A young man who took the question seriously. Albert Einstein wasn't trying to overthrow Newton. He was trying to be honest. He asked a simple question: if the laws of physics are the same for everyone, and the speed of light is the same for everyone, then what must change? The answer was unavoidable. Time cannot be absolute, not because Einstein wanted it to be strange, but because the universe demanded consistency. Time depends on motion. Here's the part that feels counterintuitive, but remains experimentally proven. If you move relative to someone else, your time passes differently, not symbolically, not psychologically. Physically. A clock moving at high speed ticks slower than a clock at rest. This is not an illusion. It has been measured thousands of times. Satellites in orbit experience time more slowly than clocks on Earth. Particles moving near the speed of light live longer than identical particles at rest. Every GPS signal depends on correcting for this effect. Without it, your phone would be wrong by kilometers. Why this does not mean time slows down. This is where popular explanations often mislead people. Time doesn't slow down in itself. There is no universal time river that gets thicker or thinner. Instead, different observers experience different sequences of events. Each observer's clock behaves normally from their own perspective. Your heart beats normally, your thoughts feel continuous, your chemistry behaves as expected. What changes is how 2 different systems compare their changes. Time is not bending. It is being measured differently due to motion. This distinction matters. A thought experiment you can trust. Imagine 2 identical clocks. Point 1 stays on Earth. The other travels in a fast spaceship and returns. When they reunite, the traveling clock shows less elapsed time. This isn't because time felt slow on the ship. It's because less physical change occurred along that path through space-time. Time is not something both clocks move through. Time is what clocks record. Space-time, the structure Newton never had. Einstein introduced a new framework. Space-time, not space and time, but a unified structure. Events don't happen in time. They exist at coordinates within spacetime. Motion through space affects how systems move through time, because they are not separate dimensions. This doesn't destroy Newton's laws. It explains why they were incomplete. At low speeds and weak gravity, spacetime behaves almost exactly as Newton imagined. That's why Newton still works, why there is no universal now. Here's one of the most unsettling and beautiful conclusions. There is no single present moment shared by the universe. What is now for you may not be now for someone moving relative to you. Point 2 observers can disagree on the order of events, and both be correct. This is not philosophy. This is the direct consequence of how space-time works, and it brings us back to our core idea. Time does not flow. Events are ordered differently depending on motion. Your experience still makes sense at this point. You might feel a quiet tension. If time depends on motion, if there is no universal present, why does life feel so linear? The answer is simple and physical. You move slowly. Gravity around you is weak. Your brain evolved in a regime where relativistic effects are negligible. Your experience is accurate. Locally, physics doesn't invalidate it. Physics explains why it works so well, and where it stops working. Why this changes how we understand reality. Time is not a background stage. It is part of the structure of reality. Emotion doesn't happen within time. Motion defines time. Newton gave us the rules of motion. Einstein showed us what motion actually means, and we are not done because motion is only half the story. In the next chapter, gravity will enter, and time will behave even more strangely, yet even more beautifully. Let's continue gently, because what we're about to discuss isn't abstract theory, it's something happening to you right now, whether you notice it or not. Up to this point, we've seen how motion changes time, how two observers, moving differently, experience different sequences of events, without contradiction, without illusion. But motion alone isn't enough to explain the universe. There is another influence, quieter, deeper, and more constant: gravity. Newton's gravity, a force that pulls in. Newton's picture, gravity is a force. A mysterious pull acting across distance. Objects fall, planets orbit, apples drop, and again, the equations worked for centuries. Gravity was treated as something that acts on objects, while space and time remain untouched. But just like with motion, precision measurements revealed something Newton could never have seen. Gravity doesn't just move objects. Gravity changes time itself. A simple but profound discovery here is the fact he measured, confirmed, and used daily. A clock closer to a massive object ticks more slowly than a clock farther away, not metaphorically, not conceptually, physically. A clock at sea level runs slower than one on a mountain. A clock near Earth runs slower than one in orbit. The difference is tiny, but real, and without correcting for it, modern technology would fail. Why gravity affects time? Einstein realized something Newton never imagined. Gravity is not a force pulling objects through space. Gravity is the curvature of spacetime. Itself, mass and energy tell spacetime how to curve. Curved spacetime tells matter how to move, and when spacetime curves, the geometry of time changes. Time doesn't slow because gravity drags on it. Time behaves differently because paths through spacetime differ. An intuitive picture: imagine spacetime as a landscape. Flat regions allow straight paths, massive objects create valleys. Objects, including clocks, follow paths determined by this shape. Point 2 clocks following different paths through curved spacetime will record different amounts of elapsed time. This is not mechanical failure, this is geometry. Time is not resisting gravity. Time is part of the shape gravity creates. Your body is experiencing this right now. This isn't happening only in extreme environments. Right now, your feet experience time slightly more slowly than your head. Your heart ages at a different rate than a satellite's clock. Every second you live is shaped by Earth's mass. The differences are small, but physics does not care about scale. Truth is truth, whether dramatic or subtle. Why this does not mean time is stretching. Again, language often misleads us. Time does not stretch like rubber. There is no universal clock being distorted. Instead, different regions of spacetime allow different amounts of physical change. A clock measures how much change occurs along its path. Gravity alters the path. The clock simply records the result. Black holes, the extreme case: if gravity is strong enough, the effects become dramatic. Near a black hole, time passes extremely slowly compared to distant observers. Paths through spacetime curve sharply. The concept of before and after becomes observer dependent. Yet even here, nothing mystical happens locally. A clock near the black hole ticks normally for itself. Physics remains calm, even when intuition fails. Why the universe doesn't need flowing time? Let's step back. We've now seen that motion changes how time is measured. Gravity changes how time is measured. Different observers record different durations, and yet physics works perfectly. No flowing river of time is required. No cosmic metronome. Instead, time is a relationship between events in space-time. Change defines time, paths define duration, observers define order. Newton revisited. With new eyes, Newton gave us something extraordinary. He gave us a language to describe motion. Einstein didn't erase it. He expanded it. Newton's laws live inside Einstein's universe, as approximations where space-time curvature is small and velocities are low. This is not contradiction, this is refinement. The quiet consequence here is the deeper realization, one rarely said out loud. If time depends on motion and gravity, then time is not a universal background. It is part of reality's structure, inseparable from space, energy, and matter. And that brings us to the final step, because if time doesn't flow, and isn't universal, then what does it mean to exist now? In the next and final chapter, we'll explore why the present is not fundamental, how physics describes the universe as a whole, why the block universe is not fatalistic, and how this understanding deepens, not diminishes, human experience. Let's take a breath. We've walked a long way together, from Newton's intuitive universe, through motion, through gravity, and into a picture of reality that feels unfamiliar, yet strangely stable. And now we arrive at the question that sits quietly behind everything we've discussed. If time doesn't flow, if there is no universal now, then what does it mean to exist at all? This is not a philosophical escape hatch. Physics answers this carefully, without speculation. The universe as a whole, not a moment. Modern physics describes the universe not as something happening, but as something existing. All events, past, present, and future, are part of spacetime. This idea is often called the block universe. The name sounds rigid, almost lifeless, but that's only because it's misunderstood. The block universe does not mean that nothing changes. It means that change is already included in the structure. Events don't move into existence, they are. Why this is not fatalism? This is where many people instinctively push back if the future exists. They ask, does that mean my choices don't matter? Physics answers calmly, your choices are part of space-time, they are not overwritten, they are not illusions, cause and effect still exist, locally, physically, consistently. The fact that an event exists in space-time does not remove the mechanism that produces it. A book already has its final page written, yet the story only unfolds when you read it. Your experience is the unfolding. Why the present feels special if there is no universal now? Why does this moment feel so vivid? The answer is physical, not mystical. Your brain is a system that stores records of past states, memory, processes current inputs, perception, predicts future outcomes, expectation. The present is where information is being integrated. It is not a location in the universe. It is a process. Physics doesn't deny the present. It explains why it emerges. Time as an emergent phenomenon. This is one of the most important ideas in modern physics. Time is not fundamental in the same way matter or energy is. At the deepest levels, in equations describing the universe as a whole, time often disappears entirely. What remains are relationships, ordering, correlation, structure. Time emerges when systems interact, record change, and compare states. Just like temperature emerges from molecular motion, just like pressure emerges from collisions, time is real, but not basic. Why Newton still matters. Let's come full circle. Newton assumed time flowed because it worked, and it still does, where it should. In everyday life, time behaves predictably. Clocks agree, cause precedes effect. Newton didn't fail. He described the regime humans evolved in. Einstein didn't destroy that world. He showed us its boundaries, seeing reality differently, not coldly. This understanding doesn't drain meaning from life. It deepens it. Moments are not precious because they slip away. They are precious because they exist at all. Your laughter doesn't vanish into the past. Your struggles are not erased. Your kindness is part of the universe's structure. Nothing is lost to time, because time is not a thief. Why physics is quietly humbling. Physics doesn't shout. It doesn't demand belief. It observes, patiently, until assumptions fall away. Time doesn't flow. Space isn't empty. Reality isn't what intuition suggests, and yet, everything still works. A final thought. If you take one thing from this entire journey, let it be this: you are not moving through time, you are a pattern of change within space-time. Your life is not being carried away. It is written into the universe, moment by moment, choice by choice. Thank you for staying with me until the end. If this perspective helped you see reality a little more clearly, like the video and share your thoughts in the comments. Physics grows stronger when curiosity is shared.